Okay, so for this problem, I'd like you to recollect maybe a movie you've seen before, which is The Princess Bride. And let's say that you're in the scene where they're running away from, I don't know who the bad guy is, and they're on the water, and they're sailing, they're trying to get away, and then they see a cliff ahead of them, and of course they're going to scale up the cliff, and then of course have all sorts of adventures after that. But anyway, if you haven't seen the movie, it doesn't really matter. So, the situation is you're on a boat that's on the water. Ignore the height of the boat or pretend like there's survey equipment that's on the bottom of the boat or something like that. So you're looking ahead, and at one point you see that the cliff, sorry, I forgot to put the measurement in there. Okay, so at one point you see that is a 12-degree angle of elevation to the cliff, and then you go 600 meters, and then you see that the angle of elevation is now 28 degrees. Okay, so the question is how tall is the cliff? So it's a little bit hard because you have to do a couple of things before you can get to that point. But the first thing you're going to realize is that what you can do is take the supplement of 28, and that's going to get you 152. Okay, all right, so the great thing is, believe it or not, you have enough information to use the law of sines with this question. If you want to summarize, you have 600. Again, this won't be to scale exactly. Let me just take a minute here to draw it a little away from the picture. Okay. All right, so you have 600 meters here, and you have 12 degrees here, okay? You have 152 degrees here. So what would be nice is to be able to find either that length or that length. Either one would be very helpful. So you could actually find either one in it and use that one. Okay, so what we can do besides that is go ahead and take 180 and subtract 152, and then also subtract the 12 degrees from that. So let's go ahead and do that. Okay, so you should get 16 degrees up in that corner here. Okay, again, it's not really to scale at all, but we'll try to ignore that. Okay, so what can you do now? You can go ahead and set up an equation, okay? Sine of 16 over 600, so sine of an angle over side of across from it, right? And then depending on what you want to do, you could do sine of 12, okay, to that unknown side over here. So I'll just call it maybe L or something like that. Okay, so then you could go ahead and solve that. So how would we do that? We could cross multiply for those. Okay, so we get L sine 16, right, equals 600 sine 12, or L equals 600 sine of 12 over sine of 16. Okay, so once you do that, you get the L, I got it anyway, is 452.577 approximately. Okay, so what you want to do at that point is if you have that L value, you can just go ahead and work with that and then use a right angle. Okay, so in other words, take this part of the picture here, just take that right triangle and rewrite that. Okay, so you'll take your L value, okay, the 452.577, okay, and you have a right angle, okay, and you also know that this is 28 degrees, okay, so now all you need to do is use regular sine in order to find the height, right, because sine would just be opposite over hypotenuse using those old definitions. So you could say sine of 28 is going to be h over 452.577. Okay, so h is going to just be the product of those two numbers. That's sine of 28, okay? All right, so running that through your calculator. Boom, boom. Okay, so it's not really all that high, I guess. It might be scalable for the people in The Princess Bride. Hopefully it is. And they make it. Okay, 212.472 meters is what I got. And of course, it's really not to scale in this problem. Hopefully you can work with that though. Okay, let's do a few other problems that you're likely to encounter some questions with. So let's look at this question generally. When is this kind of thing true? So in other words, you would want to think it's true for all inverse functions, but the trig inverse functions are kind of special because they're only defined to work kind of in that limited way, okay? And so what you really need to know for this kind of question is what kind of things come out of the inverse sine function. And if you recall, or you look at your graphs or whatever, there's a range for this one, right? So the range of sine inverse, okay, is actually negative pi over 2 to pi over 2. So if you think about it, like, if you put in an angle that's like, I don't know, 5 pi or something really extreme to the left or the right or whatever, it's not going to give you that answer back, right? It's going to give you some equivalent angle kind of to that one that has the same sine value. Okay, so, but if you start with something in here, for instance, if you think about it, it's going to take the sine of that value and then it's going to spit back whatever value was in here. So basically, it sounds kind of weird, but you actually want to work with the range you have, what you know comes out of the sine, and know, well, if those things were put in to this composition of things, they could come back out. But obviously, if you put something really extreme in there that's not in that interval, it won't quite work out to give you that very same angle back. Okay, so similarly, you know, working with this one, it helps to know the range of this function, right? And because those are the only things that could be spit out. So this one has a funky range, which is 0 to pi. And then tan inverse, this one is close to sine inverse, but the range of this one, of course, is an open interval, negative pi over 2 to pi over 2. Okay, so let's work through a couple other questions that you're likely to see. Okay, again, random order. Let's look at a question like this one. Okay, so hopefully you see something like this and it rings a bell. My hope is that when you see something like this, you think, oh, 2 sine x cosine x. I've seen that before, right? And that's the same as sine of 2x. That's not on there, is it? Okay, all right, so I would want to use that somehow to solve something like this. Okay, so what would be helpful as a first step, maybe you multiply both sides by 2 if you're able to do that. Okay, so obviously that would be 2a. And then I have this kind of thing, and I have to think carefully about what's going to happen to it. Okay, so if I look at this over here, what happens here, when I go from this to this 2 gets swallowed up, and this angle doubles. So that doubles, okay, and this, I don't know, we'll say get swallowed up. Swallowed up. Okay, so same thing's going to happen over here. That 2 is going to be swallowed up when I go backwards. And then that angle inside is going to double. So the thing is, it's actually just going to become sine of 30 equals 2a. And I bet you could solve an equation that looks something like that. So we'll let that go at that point. Okay. All right, let's do another one. Let's look at this one. Okay. So this one is close to something that's on the chart. Obviously, it's not going to be exactly that. And the one that's pretty close to it is cosine squared of an angle. Okay, let's go ahead and write it like that. Cosine squared of an angle minus sine squared of an angle. So this would simplify. This is one of the cosine double angle formulas. Okay, so there's 3 different ones for that one, so that makes that one a little more tricky. But anyway, so the problem with the way this one's written, it's actually backwards. So what you might want to do is make it cosine squared of 15 minus sine squared of 15 equals negative b. In other words, you're multiplying both sides by -1. That changes the order of the subtraction. Okay, so again, seeing this formula, the thing that I realize is it doubles when I go the other direction. Okay, so it's just going to be cosine of 30, okay, equals negative b. And of course you could solve something like that. I think that wouldn't be a problem. Okay, let's keep moving on. Some other questions that you might have. Okay, so for this one, let's pretend that you have this scenario here. Okay, so let's say what you're asked to do for a question like this one is you're asked to find the area of this parallelogram as a function of that angle x, which is in there. Okay, so you might want to look at some different scenarios for that. So if the angle were 90, for instance, then it'd be really easy to find it. It'd just be like 10 times 20. Whereas like if it were really like low, like this one, okay, and that's 10 and 20. Again, the drawing isn't perfect, but it's going to have less area. And like if you think about it, if they were just straws or something and you squashed them so that they were completely horizontal, like the angle was 0 degrees or whatever, it would have no area. So obviously it's going to be something in between 200 and no area, and it's going to depend on x. Okay, so you can think of the different things that would happen. Okay, so let's go ahead. That just tells us what to do. What you want to go ahead and do is put in a height, because the area of a parallelogram is just going to be base times height. Hopefully you know that. Okay, so what I would like to do is actually find the height. So just label a height in there and go ahead and find it. Okay, so it turns out that the height is going to be the sine. You want to find, the sine of x is going to be h over 10. Just the basic SOHCAHTOA, opposite over hypotenuse. Okay, and if I solve that for h is going to be 10 sine x. And then I'll just plug that into my parallelogram formula. The area is base times height. It's going to be a function of x, though, in this case. And I'll just, instead of b and h, I'll put in 20 for b, and I'll put in the height that I found, which is 10 sine x, there. And then you could go ahead and simplify that. But that would be the area expressed as a function of x.